I'm Carl Coffman, and I'm a principal in Relevant Building Company. Relevant Building Company takes shipping containers, new or used, and repurposes them as single-family residences. In doing that, the homes are built to code, standard UBC code, so they can be permitted, financed, lived in permanently, typically built on a foundation. And our intent is to create conversations about climate change, how we have to live differently in a climate changing world, to mind our resources, to limit our space. We're here to kind of just try to help in the movement to deal with some of that stuff. Relevant Building Company expects to become a producer of pre-permitted models, and in doing that we have to appeal to a multitude of different senses, from somebody that's building in Eastern Oregon with their 3-bedroom 2-bath house, to somebody that needs something that will just barely fit in the backyard of an ADU in Portland. So to that end, we've designed 2 20-foot units, which is 320 square feet, up to 1,400-foot 3-bedroom 2-bath houses that resemble the deluxe that we're in right now, for example. We can custom build homes for people, but we tend to prefer to build a standardized home. Having said that, everybody has a different idea for where the bedroom should be, or the bathroom, or where the window should be, and we can modify all those little elements inside that shell, that structure, that footprint that we had already. And that seems to be a real accommodating feature. So we have kind of a production home with a custom tint to it. Now we're looking at what we call a Ramona. This is a very new project for us. We have a customer who wanted to purchase one made out of 45-foot containers, and we said we like this plan so much we'd like to build it out of 40-foot containers and make a model out of it first. So here it is. What you see is that we cut out basically the entire wall of the container, and we extended the floor out so that we could frame with wood frame, standard construction, 2x6 walls, a bump out along the entire face of it. You'll see a bit later what it looks like on the inside, but it gives it a real good open space. Once it's moved to the job site, which it can move in that exact configuration, then the roof has to be added for it. It's waterproof when it's in transit, it's waterproof when it sits on the site. When you put the roof on it, it's kind of a roof over a roof, with suspenders and belts. Ramona is the newest addition that we built to our list. We got several more exciting models coming out, but this is the newest we have on site. So now we find ourselves inside the Ramona. The thing that I like about this the best is the space that I just feel in here. And typically we will always look for a place to gather as a family. We had a lot of fun with this and installing this small kitchen that you'll see in a minute. It's got some retro appliances that my son and I, my partners and I argued about, but so far I'm feeling good about them. We also like to build some furniture. You'll see some of that in other models, but in this model we're pretty proud of the stuff that we build in the kitchen, just some shelving that's made in our metal shop. So this is again, it's an 8-foot container with about a 4-foot extension on the side of it that is steel floor welded to the existing container. And then we've added a standard 2x6 wall around it, which is the same wall you'd get in a house if you built it today. And so this beam that's right here represents the end of the container, so the beam is holding up the roof of the container itself. And it is also what we're using to tie this added section on. The reason this is wood here, of course, is we want it to be wood here, but also the insulation on it is above it, and it's thermosheath. It's about 8 inches of thermosheath, which would be about R60, which is similar to what we have over the spray foam section of the roof here. So I'm 8 feet 2 inches to the ceiling. Again, these are made out of 9.5-foot tall, called high cube containers, and we're sitting right next to a freeway, and you can tell there's not a lot of noise going on right now. We're looking at the kitchen end. If I walk back the hallway, I'd go past the kitchen. You'd see a bathroom. We put a washer and dryer. We can put tubs in. You'll see showers usually. But we put a washer and dryer in every unit we build. We just feel like they're small enough. You ought to have that convenient to you. We typically use IKEA cabinets for everything. They just have figured out how to fit in small spaces. Drawers and closets are really helpful for us for space savings. We're really big on barn doors. You'll see barn doors everywhere here. This unit runs about $110,000. In that price, we include the price of the roof, that material that's got to be put on later. And we saw that outside, that this has a very long, kind of a Frank Lloyd Wright looking roof that sticks out over the front about 4 feet. And that just can't travel down the road. Although everything here, exactly as it sits, less the furniture, would fit on a truck and go down the road and drop on a foundation in someone's backyard. This is just under 500 feet, 465 feet. Also, I'll tell you that when we do pricing, we pretty much figure all the appliances are included in that price. Normally, we don't necessarily add a washer and dryer, and that seems like a little question mark or a negotiating point. About 2 weeks ago, we finished up some decks that we had designed, and they hang on the doors. We're super excited about these because whether it's a first level or second level, you can extend this out 8 feet. It's a simple add-on, a component that somebody can buy in different dimensions if they want it. Some people prefer to have the doors closed and no window here at all, but we're super excited about them, and they're all galvanized up and use 4x pressure treated material. They're plenty durable. So we'll walk around the site. You can see where we're standing now is kind of in the end of the yard that has containers coming in that are new or used containers. They're all high cube, meaning 9.5 foot tall. When we get done, our ceilings will end up being taller, about 8 feet 2 inches. And that's just what's kind of behind me is that start of the operation. So we're back at the very beginning of the production cycle when we take a container. This is one that has come out of the shop. We're building into a step 2. That means it's got 1 bump out in it. The features that I'm most excited about are things that deal with durabilities. So this is a window that's been cut out and replaced, so it's all welded up and caulked up and it's painted. What I'm excited about is that this little roof up here is covering any trim that we put around this window when it's all up. We've noticed that when we built these the first time, we didn't have that. What we got was rotten windowsills, and we worry about water infiltration and things like that. Right above it is a vent box that we have built, and we installed those light boxes. You see that there's a little bit of a flashing on the face of that light box, a little thing sticking up. All it's doing is keeping the water from running in the light box so it doesn't short out and run down the wall to the switch. This is a standard container. All of the doors built the same way, 2-inch tube around it. This could be 2-inch or 4-inch, it could be any tube. It's just something, it's all engineered. It's all part of a process you have to go through to really build one of these to code, is to have a stamped engineered plan for everything that we're talking about now. This is the container that just came out of the shop. It's been painted up, it's been caulked, it's ready to have windows installed. Floor needs finished off, and we'll talk through some of that now. So I'll start at the doorway. This container is going to get insulation above this floor. So this will get painted to encapsulate anything that's in this floor. Then it'll get 4.5 inches of thermosheath insulation on it. Then it'll get a layer of plywood on it, 5/8 inch plywood. And all that will end up coming to the very top of this pan right here. And the door will sit in that pan. So any water that comes in that door by hook or by crook gets directed back outside again. That pan is 14 gauge steel. It's not a real thin piece of metal, but it's kind of what we use on everything. If I go over here, you'll see that we've got a bump out here. This bump out gets spray foamed with the rust inhibiting paint, and then we'll build studs in it, we'll build the floor on it. But you can see what we've done is we basically, and this is what we do for every floor that you've seen so far that's outside, this is what we would call a bump out. And it's got a channel frame floor welded to the container. This is all engineered. Obviously, you can't just cut this out and assume you're going to be able to fill it in with something and have it approved by any government agency unless it got a stamped engineered drawing to support the building. When we get it done, we caulk everything all up. So if you look closely, if the camera can even see them, you'll see little white areas up there. We're super weird about this. I'm super weird about it. I want to know that if I see that caulk coming through the crack, I know that it's oozed through. I know that it's locked in so tight it can't just fall out. You can't even just take it out from the outside. So on our standard practice is to weld anything that's on top that gets rain, weld it entirely along. But it's a long process. So when we come down to vertical walls, we will skip areas. So we will stitch weld it, and then we'll have caulk that will fill in any gaps between it. So we walked into what we call the step 2. The beauty of this unit is that a normal container, when it's done, the way we do it, which is, again, spray foam on the inside. We don't normally cover any of the outside or try to doctor it up or try to make it look like a house. We do all of our spray foam, stud work, plumbing, electric, and drywall on the inside. So when we're done, that's 7 foot 2 inches wide, and 7 foot is a legal room by code. So we tend to like to put bump outs on them. So I'm standing in the bump out. I'm literally outside of the container now. We use a lot of these high windows. We think they add a lot of light. This is a very light room. And we retain the wall space so I can have my couch here and I don't have to worry about somebody looking at the back of my bald head. Because we built a code and we follow all the exact same regimens that a code-built house has, there's just certain cost to that. Everything that we build has got an induction cooktop, convection microwave, heating and air conditioning by using a mini split heat system. All of our homes are built to Energy Trust compliance. Energy Trust compliance requires 3 or 4 things. The top ones in my mind are insulation is 10% better than code. All homes require a fresh air inlet of some sort. We do that by the use of an EVR, which is right on the wall here. We make various models like this. We have a step 1, which is just a standard container, no bump outs at all. It's called a step 1. Step 2, we made it a little bit bigger. We added a bump out to it. The one we're in now is a step 2. It sells for about $75,000. It's about 420 feet maybe. And it's probably the cheapest unit that we make that's as livable as one could really expect. So we're outside looking at these raw containers. Again, we call these shells because there's nothing done except build a shell. Don't have any windows in them. But this view of the side of a tea house, this is the 40-foot section that has a couple of bedrooms in it. It runs, that 40-foot section, you can see this bottom is all bumped out. There's a 3-foot bump out, then a 2-foot bump out, then a 3-foot bump out, making up this entire wall. When you cut a wall out of a container, you take all the strength out of it. You can't just weld something back in unless you have engineering for that. When we provide a container, inside of that or with that comes all the engineering, all the thermal calculations for it. Structural engineering is probably one of the most critical things that we do. It has to be designed to withstand wind loads. If it's too tall, it's going to get, it's like a big sail. It has to withstand earthquake codes. All those things are part of getting a building permit. So that again, this is not an RV. It's not a travel trailer. It's a home built to the same code that any other home in Oregon is built to today. So I'm just trying to stress the importance of the engineering. So we're now standing outside the tea house. It's named because it has 2 20-footers teed into a 40-footer. The door is in the 20-footer. We're kind of big on plant wall, so we were just talking about the plant wall that's out here. There's one on the right-hand side of the container that'll grow up and grow around the eyebrow that's over there. We make this with a canopy. It's almost more like an umbrella than a covering because rain can kind of get around it. But it gives it a good look. We also have an optional roof that can be put on it that's all engineered, and it just puts a real shallow sloped roof on it. Let's go on inside. So we've moved inside the tea house, and I'm standing in the 2 20-foot sections that are split right here. Again, almost all of our units, you'll see a glulam beam that attaches and supports a roof on each side. And then when we set them up, we put a piece of trim over the top of it. This is also a great, comfortable family space. Some people would call it a great room, although it's a small great room. I think right here you can probably see that it feels to us like it's a little bit too small of a space for a full island. So we had our welding shop put together this movable island that you can just set anywhere you want, and you've got an island or a buffet or whatever you want it to be. But the rest of the space lays out pretty nicely. Now, if we walk through the door, you'll find two bedrooms, 1 bath, and a laundry facility. The appliances in here are pretty nice. Again, you can see the IKEA cabinets. These cabinets here happen to be made from recycled material, and you'll see a little bit of our other handiwork in the wine holders and in the cabinets up in here. It's been fun to watch the welding shop who takes joy in building some of these artistic features that we like to show. So at the front of the tea house, at the front door of the tea house, is a bump out. The bump out is something, for some reason, I don't see container modifiers doing. And we stumbled into it, which is a story over a beer sometime. But right now, you can see that we've added about 3.5 feet to the side of this container. It can still fit on a truck. It can still go down the road. It gives us a lot more space in this room. The bump out is made of basically the piece that we cut out of this wall. We moved out to the outside wall, cut windows in it, and attached it with steel and welded it all up. Obviously, you have to have engineering to have that done correctly. Including the bump outs, and there's 3 on the other 40-foot unit as well, but this totals up to about 775 feet. So as it works out, it's legal to use as an ADU in Portland because 800 foot is the maximum size. And it's interesting that we are selling these as ADUs. We've sold a couple of these in that purpose. This sells for about $150,000 at our shop. By the time we get it on a truck and down someplace and build the foundation for it, hook it up to utilities, they'll probably add $25,000 to $40,000 to that. But under $200,000, they've got it set on their lot. So we're in the kitchen now, and this is right where both containers come together. And again, you can tell by the glue lamps. There's one glue lamp on each side, and they're split in the middle. And this piece of wood, if I took it off, you'd see the crease between them. This piece right here is basically just a fill-in, and it's covering where all the electrical from these 3 different units. We got lights over here and lights over here, but they all come together into here. So if I took this off, you'd see a big box up there that all the wires go into, and that connects it all together. When we move this container, we'll pull this pantry out of here, and we'll disconnect all those, and we'll ship this as 3 separate units on 2 trucks. 2 20s fit in one truck, and one 40-footer fits on the second truck. Now we're going to go down the hallway and show you a bedroom. So this is the bedroom of the tea house. Notable points about the bedroom are it's about 12 by 11. We've evolved to just using IKEA cabinets because, again, they just have small figured out. So in our small spaces, we can get drawers built into the closets, and it eliminates the need for a buffet in here. This room is also larger because you can tell when we do a bump out, the ceiling is notched here because there's insulation and stuff happening right there. So all that is just bumped out, and it's all part of a steel build out that we put into them. Makes the room really comfortable. This bump out carries through the bathroom, the laundry area, and into the second bedroom that's in this unit. So almost this entire wall has been pushed out 2 to 4 feet. So now we've moved up into the inside of a container. It's not a finished container, but it's nearly done. What you're looking at now is the closed cell spray foam that we're using. This is actually called, I think, Heat Lock, and it's made of a soy base. It's got very, very little off-gassing. It actually was referred to us by Energy Trust. We try to actually meet Energy Trust compliance in everything we build. So what that means is that our insulation will be 10% better than code requires. We will put fresh air into each one of our rooms. This will have all kinds of ventilation, heat, air conditioning, all the typical stuff you see in a regular code-built house. I don't think I've mentioned yet that we are built to the same exact code that you'd build a house today in the United States. One of the other benefits of shipping containers is stackability and portability. They can be picked up and relocated. You can build shipping containers on foundations that are completely removable by simply unconnecting them. And they don't have to be welded on. They can be connected with the same exact devices that are used on ships. So here we are at the foundation level of one option for foundations. Most of our foundations are really built as a stem wall around the perimeter of it, because when we put the plumbing in, we can stub through the floor, and then we can pick up that plumbing in a crawl space like every other house made, and we can carry it any place. This model, we wanted to sort of explore how else to do it, so we bought the same exact thing that they weld to the floor of a ship right here. They call it, coincidentally, a foundation. And then we connected it with the same item that they use to attach containers to the floor, and that's with the twist lock. So now I've disconnected it, and then I've reconnected it up again. You'll see the end of that you'll see the end of that same little piece of steel if you look up here, because we've connected the two containers with the exact same twist lock. When we go with multiple container heights, we think we can go 3 high. We have not done that yet. This is as high as we've gone, as 2 high. There's access issues and ADA issues and different things that come in that we have to kind of work our way into that. But so far, this is as high as we've gone, as 2 high. This is a project that we started about 3 years ago to build condominiums in St. Helens. We finally are on the verge of getting our permits, and so now we've taken it down to modify them to today's standards. In the last 3 years, we've learned a lot about how to convert containers to houses, and we just don't want to send something out that's not done to the best that we know how. So we're in the metal shop now. I'm going to explain to you what we're looking at here. I'm standing on the meet point of 2 containers coming together. So we've removed this wall. This is one container. We'll have another container right here, and that will make a 16-foot wide by 40-foot long unit that will become a 640-foot, 1-bedroom, 1-bath condominium. It'll be one of 8 that will be built on government-owned land in St. Helens. We're very excited about this project. It's a pilot project to find a different way to work with government on affordable housing. On all of the units that we build, our standard process is to put a glulam beam to carry the load of the roof. And kind of a rule of thumb is, depending on the size of the beam, you need to have a post every 20 feet or so. So we bring that beam to a post here, and we design so there's always a wall or a reason to have a post here. But we span the entire length of this 40 foot with that beam so that when we lift it, it doesn't come in pieces. It all is kind of one part. People ask me sometimes, why shipping containers? And what are the faults of shipping containers? And I'll often be asked things like, what about rust? Or what about durability? You know, again, why? Shipping containers are made of Corten steel. Corten is not a rust-proof steel, but it forms a self-sacrificing layer. So when it gets rust, it won't spread. They're also made for marine conditions. They're sprayed with a durable spray paint, so they hold up against weather extremely well. Somebody buying a single-use container, which means it's been used one time, but when it comes to the United States, it's not going home, can almost rely on a blemish-free paint coat on their container, which will last for an immense amount of time. Again, containers are made to stack 7 high on a ship, loaded with 50, 60,000 pounds in them, and sent out on the ocean in basically earthquake conditions. So ruggedness and durability are inherent in their design. I will tell people, if you want a 1,000-year product and you build it out of a shipping container and you put a roof over it that you'll replace every 40 years, you'll have a 1,000-year product.
Thank you for watching our video and for stopping by Tiny House Expedition. I'm Alexis.
And I'm Christian. Don't forget to like, comment, and subscribe.
And for more tiny home tours and stories, click the videos below.
And join us on Patreon for bonus content,
including face-to-face conversations with us. We hope to see you there.
All right.
Thanks, guys.
Have a good one.